Hey, have you ever thought why people die during cyclone? Is it because we don't have data or we don't have prediction? Neither of them. So we have both. In fact, we have more data than we think of. But the real challenge lies in how the data is understood, acknowledged, and used for decision making. That's where we started our journey in building this Sahayakmap. This is not just like an ordinary project where we are building something for the sake of gaining some traction, but this is really something we are building for the sake of people and towards saving the lives of people. If you ever thought about like what happens during disaster, the commander who is really working towards saving people has to work on multiple different sources. He has to keep watch on river gauges, the radar, ISRO details, and then the OpenStreetMap, ADS details, and a hell lot of things. And by the time he gets all the data in hand and he tries to understand every single parameter of it, the disaster would have already happened. The flood would have already come forward. The people would have already died, and assets would have already displaced. And that is one single moment nobody can do anything. And that is the core pillar of our application. So, what we are doing here is we are ingesting data from various different sources and feeding them into AI as an intelligence and getting the right direction and giving a right suggestion for the NDRF commander or whoever it is to take right action. So without any further delay, I'll just quickly move on to what our intelligence layer is built about. So this intelligence layer is built on various parameters. The telemetry, which is being ingested from 6 to 7 different sources on hourly basis and making all those unstructured signals into structured and getting that pushed into the dashboard, which will help the commander-in-chief to take a right decision. So we are now only at the V1 version, so there is a lot more to come. We want to make it live and we want to make it really production ready application. So moving on to the live dashboard, so this is what you see as a live dashboard here. For the V1 version, we have only collected data for 2 different districts. One is Odisha and second one is Andhra Pradesh. So I can choose any of this. For example, I'll go to Andhra Pradesh. You can see a lot of data here. Majority of them is self-readable. I will not go into details of it. But quickly moving on to dashboard. This dashboard is one-stop solution that gives the details of every parameter the NDRF Commission or anyone for that matter will be willing to look at. So I'll give a brief of what this each and every parameter or each and every asset is about. So on the top you can see data ingestion. So here this is the main ingestion source. At the moment we are ingesting the data from 6 dynamic sources and 1 strategic source. The one strategic source is about roads, bridges and culverts, NDRF asserts, relief camps, everything. That is not going to change every now and then. So that is considered as a static data ingestion. Whereas these 6 are dynamic ingestions and we are ingesting the data every hour. But whereas when we go into production, we want to make this ingestion happen every 5 minutes. And next you can see the assets. So these are all the tactical assets. These are not the original assets. We fed these assets into database for our demo purpose. So for example, you see here there are 67 assets within Andhra Pradesh. So they are divided into boats, helicopters, trucks, ambulances and drones. And at any given point in time, when someone like NDRF commander or someone who sends some assets from one place to other place, those can be really visible here. So that's why you can see among 67, there are 7 in transit. Those 7 are something which are displayed here. Here, as a part of our simulation, West Godavari has a high volatility and the flood is already inundated the part of West Godavari. That's the reason like we are sending a lot of assets from Anantapur, East Godavari, Krishna, Guntur, West Godavari into the actual target. That's how we see in transit as 7. And the next part of this is camps. So there are 2 camps within Andhra Pradesh, which is again simulated data. So whenever an asset movement happen, the camp as well will get filled up. So here there are 2 camps, and then 2000 so among the 2 camps there are 2650 people who are sheltered, which clearly says there is still 33% of occupancy, so that they can take a decision on whom to send and where to send. And moving on to the right of this, we have got 2 different structures. One is the map layers, the other one is legend. Legend is anyway self-explanatory, which talks about the red as critical alert and orange high alert and all those things. I'll come to that in a minute. And the most important part is the map layers. So here you can see multiple map layers. So for example, if we go into any of this and then click on that, it will take us to the right place. For example, here on the left hand side under the critical alerts, it says West Godavari coastal inundation extending inland, which means there is a high chance of this getting flooded at any point in time. And what we actually have to do, so this will help us to take a decision. So here, for example, it says the AI is 91% confident based on ISRO derived SAR data and based on the IMDA and CWC, everything into consideration. So here let's talk about this one place. Here there are 3 different alerts. Number 1, it's about IMD forecast. The IMD forecast is real time, it's not simulated data. It says 0.1 mm of rainfall, and the wind, everything is extracted from Open Meteo database. Similarly, if you see, there is one more IMD forecast. So whereas this is IMD forecast which talks about 0.1, and there is one other part like which talks about another IMD forecast internal which says the same 14.2 kilometers per hour. And there is also one more thing which you really be excited about is the tweet. For example, given a scenario where the IMDA forecast or the ISRO telecast summary says everything is normal, but suddenly there might be a tweet saying somebody is flooding. So we will consider those tweets as well. So you can see all those citizens' tweets here. So basically our AI goes forward and extract the information of tweets, IMD rainfall, ISRO and all those things, and then give a decision or give a suggestion to the commander who are in charge of taking a decision. So similarly, you can see a lot of assets here, and these are all bridges. This blue color, yellow color, all these lines are the roads, and these are static data which we extracted from the government database. And there's also something you can see here as detail. So detail talks about the smaller roads, whereas the blue and orange talks about the major roads. The detail talks about, give the information about the smaller roads, the black. And for example, if someone want to go and make any road as impassable, for example, let's take a condition where the commander-in-chief got a phone call saying this particular road which you see on screen is flooded. So he can directly come here, he can click on this, he can make this impassable. What that means is, whenever a road is made impassable, okay, for some reason it's not working really, so let's make it degraded. So when the NDRF chief makes a road as degraded, any assets that coming via this road will take a alternative route. So that is the reason why this is very important. So this is one major importance of this. And on the right hand side, you can see many layers. For example, if someone want to see, let me untick everything so it will be clear for you what I'm going to talk about. I'll go one by one. First, let's talk about the live aircrafts. If you see in Andhra Pradesh, there are about 10 aircrafts which are flying. This is the real live data which is picked from the Open Sky network. The reason why we need the live data is, as a part of our assets, there are few helicopters as well. To track the helicopters, we need to track these aircrafts as well. Once any of our asset is logged into OpenSky network, we can see that alert, we can see that helicopter live movement. That's the reason for this aircraft. So next, moving on to ISRO inundations. So at the moment, there are only 2 ISRO inundations. So this is again simulated because at the moment there is no ISRO inundation. So there is no inundation in this region because we are not even in the winter. So this is the way someone can see. If it is in blue color, which means this is slightly inundated. Whenever the inundation is more, it will become orange. When I say inundation, it's about like how the flood is being filled up. And next is IMD rainfall. So this is the rainfall. So wherever you see a rainfall, there is naturally there will be an inundation. Okay, if the rainfall is more, the inundation will be more. And similarly, there is something called CWC gauges. So CWC gauge is the river gauge. So river gauge is something like where how the rivers are being flooded, how the rivers are being overflown. Similarly, you can see citizen aircrafts, active alerts, relief camps, NDRF asserts, culverts, the small type of bridges, and then the major bridges, roads, and then the flood zones. This is how this entire map is built for. And on the left hand side, you can see critical alerts, high danger alerts, and then elevated risk. All this data is simulated at this point in time, but when the real disaster occurs, we wish this solution works perfectly fine, of course with a lot of changes and then the features. Okay, and the last one is about the SDMA directive. So at the moment, SDMA is not giving any data via APIs. So what we are doing is we are scraping the data from the journals or from the news information that is being given by SDMA directives, and that will feed into this. However, at the moment, this is all simulated data. So that's the overall view of this, and I'm sure we are going to make this more production ready in the coming future, and this will really help towards the disaster recovery. Thank you.